Again, pop up to slide 2. Feel free to actually look at mine for now. Look at the meat for now, and then when I open up, I want you to stay on the meat for slides 2 and 3. And then after that, then you can go ahead and I'll open it up a little bit more, okay? So again, we're going to continue our conversation and discussion about slope and y-intercept. If you think back to what we talked about on Tuesday, we talked about slope and y-intercept from a graph. For slope, we made a triangle and then we counted either up or down, that's the rise. If we counted up, that number was positive. If we counted down, that number was negative. Okay, and then we went side to side. That number is what we call the run. If we went to the right, it was positive. If we went to the left, it was negative. Today, we're going to take a break from graphs and we're going to look specifically at tables. But it's basically the same idea. You are still looking for how much the y changes and how much the x changes. But instead of looking at a graph, you're going to look at a table. In addition to slope, you're also going to look at the y-intercept. Thinking back to y-intercept, we've talked about y-intercept being the starting value. On Tuesday, we looked at a graph and we found that the y-intercept is where that line crosses the y-axis. And the coordinate pair is always 0, something. So as you look at this slide 2 on the Google Meet, we write that as a coordinate pair of 0, something. And if you look at the table, you're always going to look for where x is 0, and then there's your coordinate pair sitting right there in the table. Now, the next thing, like I talked about, is that we have slope. It's the change in y over the change in x. The other day, we talked about slope as being the rise, right? How much you go up or down over the run. And the terrible R. And the run is the side to side, okay? That is slope. Just because we're looking at tables today doesn't make it any different than what we did with the graph. You are still going to count. So technically, if you had dots on a grid, 0, 4, and 3, 10, you would make that triangle and you would notice that you would go +6 to go from 4 to 10, and you would go +3 to go from 0 to 3. So remember, the 6 is that rise, and the 3 is that run. So however the y numbers changes goes on the top, rise goes with y's, and run goes with the x. Now, one thing to notice is that if for some reason you're struggling with trying to figure out exactly how much it changes by, but I know that 4 plus some number gives me 10, I can actually backtrack to figure out that value. I can do 10 minus 4 to figure out that difference and use backtracking. And honestly, if you need to, there is nothing wrong with grabbing a calculator to doing that backtracking to make sure, I don't even remember what it was, 10 minus 4, to make sure that you are figuring out that pattern. So there's that +6. Okay, so one thing to note that you can use, hey Mia, switch over to the meet, please. You can switch, you can use your calculator to find that difference. All right, so before I open up slide 3 to you guys, I want to talk about, this is the slide I need. There. I want to show you one more example of how you can find slope and y-intercept from a graph. If you are in the Desmos, can you just switch over to the Meet so you can see me do this example with you, please? Tabari, Layla, Kevin, Jack, Bryant, Benjamin, Alan, slide 3, or actually switch over to the Google Meet so you can see this, please. Dylan, switch over to the Meet, please. Tabari. All right. So again, we're going to identify both slope and y-intercept from this table. Again, the slope is the change in the y. That's what we call the rise. That says rise, believe it or not. And then we've got the change in X, which is what we call the run. And we're going to do that by looking at the table. So the first thing I'm going to do is look at the table. Now, notice it goes from -3 to -1, and then -1 to +1. If you think, oh, those negative numbers, I'm just not quite sure how that changes, but I do know it's going up by something. This is where you could use your calculator to do the opposite and work backwards. So if I worked backwards, I can do -3, excuse me, I can do -1 minus -3 to check my math, -1 minus -3, oops, clear, -1 minus -3 equals, oh, it's 2. So then I can go here and say to myself, all right, so that must mean it increases by 2. And then I go over to the x's and I do the same thing. How are the x's changing? Oops, I should switch colors so I have it all the same. How are the x's changing? It's going up by 1. That is your run. So in this case, our slope is going to have 1 in the bottom because that's our run, and it's going to have 2 in the top because that's our rise. So then you can type this in on your slide as 2 divided by 1, or you could just do 2. Okay, now the other thing that you could have done to find your slope is you could have looked down here to the positive numbers. Sometimes we like to work with positive numbers more so than the negatives. Oh yeah, I know. 3 plus 2 is 5. That's my run, my rise. And again, I go from +1 to +2. That's also going up by 1. So it's just another way to show you how to find that slope. Okay. Then the next thing is we need to find the y-intercept. Recall that y-intercept is always where x is 0. Y-intercept is always 0. I don't know why my lines aren't curvy. 0, comma, something. So all you're going to do is go to this x column and you're going to look for 0. And then there is your coordinate pair. So I would write my coordinate pair as 0, comma, 1. Slope will be a fraction. Y-intercept will be a coordinate pair. I will leave my slide 3 up. Copy my slide 3 onto your Desmo's slide 3. And then in a moment, I will open up slide 4. All right, so again, you're going to go back and forth. You're going to copy what you see on my slide 3. You don't necessarily have to copy all of this stuff up here. It would be useful. It would be helpful. Okay, I definitely would show my work that I see down here in the table to help reinforce the idea about finding slope and y-intercept. Mateo, Ben, Henry, and Alan, you should be on slide 3, please. All right, when you're done with slide 3, go ahead and try it on slide 4. Great question. Let me, okay, I'm going to leave, let's see, what do I want to do? I'm going to leave the writing on here, Xavier, because there are kids who are flipping back and forth for copying them. But let's start with Y-intercept because I think that one's the easier one. Remember, we talked on Tuesday that the Y-intercept is always wherever X is 0. So what I'm going to do to find the Y-intercept is I'm going to go to the X column, and I'm simply going to go down here and just look to find out where X is 0. And then whatever is next to it, this right here is our coordinate pair for the Y-intercept. That's a great question. I will get there in just a second. Is that remind me, is that on slide 4? Is it missing on slide 4? Can't remember if slide 4 shows it's missing or not. Okay, so that's a great question. There's one of them. Hang on. I'll come back to this, you guys. I just want to see because there is one of them. Slide 6 has it where it's missing. So you guys switch over to the meet just for a quick second, and I'm going to show you something on slide 6 to answer Xavier's question. What if the 0 isn't in the table? Can you switch to the meet, please, so you can see slide 6? Because I don't have it unlocked right now. Ben, Alan, Dylan, Henry, Kevin, Layla. Thank you, Mia. Switch over to the meet so you can see the screen. So Xavier's question was, how do you find the Y-intercept if there's no 0 in the table? This you're gonna back the table up until you do see 0 in the table. So you're gonna modify the table on your own. Here's what you're gonna do to do that. The first thing that you want to do is find out what's happening in the table. I know to go from 5 to 13, I add 8. And then I go here. I know to go from 2 to 4, I add 2. So this also kind of goes to your other question, Xavier. You had asked for another example about finding the slope, right? So here, this plus 8 is my numerator. That's my rise. And this plus 2 is my denominator. That's my run. So I know my slope is going to start as the fraction of 8 over 2. X is the denominator, the number on the bottom. Yep, denominator is down. Yep. Now, the other thing I also notice is that 8 over 2 can be simplified. And the reason why I'm going to look to see if I can simplify it is that's actually going to help me figure out that Y-intercept, which on slide 6, like we said, is missing, right? What this actually means now is for every 4 that the Y goes up, the X goes up 1. So I can backtrack. Let me pick another color here. I'll backtrack with red. So if I go back in the table and I go back 1, that's 1. Which means going back 4 from 5 would be 1. And I'm going to go back again to be 0. Oh, there's my 0, so that's going to be my Y-intercept. And then I'm going to go back 4. Maybe I should show that, minusing 4, subtracting 4. So it would be -3. I subtracted 1. And again, how did I do that? I found our slope by 8 over 2, and then I have to backtrack. So I simplified, and then I backtrack to find that Y-intercept. I think I used orange on the other slide. So on slide 6, your Y-intercept is 0, -3. Did that? Yeah, you know what I'm going to do right now is I'll actually open the slides up so you guys can copy my slide 6 so you'll have it. The other thing that you could do is take a screenshot. But anytime you want to come back into this Desmos, whatever writing you've done on the slides should always be there. Kind of like a Word doc when you type a story, the words stay there. Is that what you're asking? Yes, I apologize. Yes, everything will still be there and you will still have access to it. It's a little different than when you submit one second, Brian, when you submit when you submit a Google Doc in Schoology, you don't always get to have editing access to it. You'll be able to go back in here and change stuff if you need it. Yeah, you're welcome. Brian's question, comment? Yeah. Yeah. Are you on the one where it changes by 0.5? Yeah. Yep, that's fine. I'm going to leave slide 6 up here, you guys. Those of you who are not on slide 6 yet, could you scooch up to 6 and copy what you see on mine so you have that writing? And then I want to go back to slide 3 so everybody can get that. Okay. And then I'm actually going to open up the rest of the slides for you to keep working. And as I look at the slides, I will give you some feedback in GoGuardian. And if you have any questions, I sure hope that you ask.